All right, thanks, Matt. So yes, as Matt said, I'm been around for a while. I've been doing this for a while. Um, what is really interesting is, as you can see, I'm on a lot of different social media, but one of the ones that's really made a big difference for me over the past couple of years is live coding on Twitch. So I started live coding on Twitch actually now 2 years ago. So it's my 2 year anniversary of live coding on Twitch. And what that's allowed me to do, I mean, I've been doing training for a long time. I've been doing Java since Java was available outside of Sun. And but what live coding on Twitch allowed me to do was actually really think about what am I doing and be able to really sort of look back and reflect. And so I've always, been sort of leaning towards making things testable, testing, unit testing, developer testing being something that's been, part of my early development history. And certainly things like test-driven development and so on are really, um, really important to me. Uh, and really, especially over the past uh, 5, 8 years, um, the testability of things has really driven how I look at software development. So as I mentioned, this is what, if you came in and watched live coding on Twitch, if you found me, this is something you might see me doing. And these days, I pretty much do almost everything test driven. And so again, sort of what that's allowed me to do is not just do it in front of, a bunch of random folks who always ask interesting questions or make contributions, but it there's something about being able to watch yourself do something that I think is super powerful. Um, what it's allowed me to do is say, why did I do that? And when we're developing, typically, right, we're not usually recording ourselves, and so we don't have that opportunity to sort of review and see, why did I make that decision? What was I thinking at the time? um, why was I stuck? um, wow, that worked out really well, I forgot exactly what I did. And so these kinds of things, I had no idea that that was going to happen. I just wanted to code, and this was a way to sort of not really mob program, but at least program with others, socially. And so this is actually something I now recommend when I'm teaching, that folks do is when you're working on something, a side project, record yourself. And it most of the time maybe you're not doing something interesting, but you may find that you can sort of gather and discover heuristics that you're following. Maybe you thought you were doing something one way and it turned out you were doing something actually quite different. So this idea of sort of uh, allowing you to reflect on what you've done has been sort of where a lot of the things that I now teach come from. So as I mentioned, I do a lot of training, online code coaching. This is a class that I recently started. Actually, I guess not so recently. Now it's 5 or 6 months. Um, uh, Started teaching, and it really sort of was the first course where I finally felt like, yes, this pulled everything together that I really feel professional developers should know, especially if you're working with Java or similar languages. Um, so just a note, I'm experienced at watching chat. So if you have a question, if you have a comment, feel free to just type it in chat, and I'll notice it. And if it's a question, then I'll try and answer it. Um, if it's a long question, don't type in the whole question unless you feel like it. Just say, "Hey, I have a question," and I'll have you unmute yourself. All right. So with the preamble out of the way, primitive obsession. Um, this is what we refer to as a code smell. Would anyone care to define primitive obsession as they know it, if you're familiar with this primitive obsession code smell?
Isn't that, Ted, where we use ints and strings for everything and not creating our own class because memory speed and other things that are probably not true anymore?
Yeah,
Coding is if you're not in an object-oriented language.
great. Yes, yes. So, so first, the first word is primitive, and so what they are, often we think of, especially in the Java language. And again, I'm a Java developer, so all this is in that context. Although some of it does apply across languages. For languages that, like Java, that's statically typed, this is especially important. So we usually think of primitives in this way, like ints, long, chars, or chars, depending on how you pronounce them. These are the usual suspects. Other ones that we may come across are Booleans. And Boolean is interesting because one of the things that I find is that often there's a state machine in hiding. And one Boolean begets multiple Booleans, which then have to coordinate and work together. And you basically have just recreated a state machine, except not in a way that's necessarily easy to understand. Strings lead to basically stringly typed code. So not strongly typed code. I wish I had made this up, stringly typed, but stringly typed code, where lots of strings are used and compared and so on, instead of using something else. The last category of list, map, and set, which is basically all of the what you call kind of abstract data types. These I consider primitives as well under this code smell. And so often there's a lot of rich behavior whenever you come across these. In my experience, I remember years ago, always finding that when I was using, a map and a hash map and the code around that, it was like, this really feels like, oh, it didn't take much and there's already a bunch of behavior. This should be a class that basically wraps that abstract data type. I hadn't thought about it from a primitive obsession standpoint, because that word primitive usually leads us to sort of the first two or three of these and not the abstract data types. But really the issue is more about that they're unconstrained. And so one of the things that really, this is when it crystallized for me, is when I realized that it's not just primitives, it's any type that doesn't have any built-in constraints. So lists, well, they can be empty. You can throw a bunch of things in, even if they're generified, as we'll see later in like the blackjack card game. You have a list of card. It still means I can throw any card in there. I can throw a bunch of cards. I can even throw maybe duplicate cards. I can not have any cards at all. And so it's still, even though it has some aspect of what it can hold, what you can do with it is still unconstrained. And so then the question of, now that we've sort of defined sort of what they are, they're basically these unconstrained types. Where we find them is what's sort of leads us to figure out, is this actually suffering from this code smell, or is this just, something that's okay? And again, code smells, this idea of finding something that maybe isn't quite right. It's not 100% the case that because it looks like this, it's definitely something that's broken. Code smells are a signal, and we have to look and smell and see and hear these signals. But we don't necessarily always have to act on them. So typically where we look for this code smell is as fields, as instance variables of a class. And this is kind of the prototypical definition for the code smell is, there's some instance variable in a class that is an unconstrained type, and maybe it should belong somewhere else. Maybe there's some behavior somewhere that needs to go with this definition, this variable. So that's kind of the primary thing. But what was interesting when I first started teaching the class where primitive obsession is one of the main things, is this is these other places where primitive obsession can be found, or at least a form of primitive obsession, or at least something to start to think about. Maybe there's something that we can fix here. Maybe there's actually a problem here that we're so used to having that we don't even notice it. And that's something that that I see a lot in code bases when I'm coaching folks. And we often refer to this sometimes as an anemic data model, where we have just a bunch of data and then somewhere else is a bunch of behavior, and it's as if object-oriented programming wasn't a thing. But we see, I know I see this a lot. And it's not, I don't blame developers like it's your fault, you should know better. In fact, if you look at the way a lot of this stuff is taught from day one in university or other places, I remember sort of the prototype, like as a trainer who does this stuff, I also watch a lot of other training to figure out how I can improve. I wish I had a lot of good examples to choose from. A lot of what I see are, hey, welcome to Java, let's go create a class called student, and they have a name and an age, and then we'll create getters and setters for it. And I'm like, no, the whole point is not about the data, it's about the behavior. And so this is sort of the end result of as an industry and as in academia teaching it this way, is we end up with anemic data models. And this code smell is a great way to find them. So the instance variables are one way. But when I started teaching it, someone asked about, hey, what about the return value? And I'm like, that's not typically the way I think about it, but let's explore that. And through some discussion and then me thinking about it more, I realized that actually there's a whole lot going on that I think I've done intuitively that I can now sort of express and talk explicitly about. So Artie asks about a default constructor as the devil. I don't think their default constructors are a problem. Maybe there's something else you're getting at. I think, yeah. So I'm not sure if there's something else you're getting at there. So if you see return values, and that's returning a primitive, right? If a method's returning an int, why are we returning in this unconstrained piece of information? Is that okay? Is there something going on here? So we're gonna touch on that a bit. And method parameters too, is there are a lot of methods taking this same unconstrained variable that maybe tells us that this class is doing too much. And so one of the things that I found is, lots of discussion. I see, folks, like Micah Feathers and other folks talk about, and we see single responsibility principle and splitting up classes. And sometimes these are great principles, but a lot of times I find people don't know how to apply them. And so one of the things that I found is that with primitive obsession, the way that we solve it often solves those problems and makes the things better, but provides a real directed way, a real prescriptive way to fix it. So when I see things like just instance variables, I'm like, okay, there may be something here. When I see method parameters that take similar things, I'm thinking maybe there's a way we can slice up this object. The place where I don't worry about it too much is local variables, right? That's that's code that's going to do some operations, and as long as it sort of doesn't leak out of that method, then I'm fine. Very true, Bob. Yes. Unfortunately, a lot of people learn software engineering in university and then never unlearn it or learn differently in corporations. And I'm sure a lot of us encounter that when we go in to companies or in companies. I mean, I'm teaching this class to folks that have 10 years of experience, and they've been in large companies, you know, public companies, and they don't know some of this stuff. And that's, you know, but that's a whole, I'm well known on my Twitch channel to rant about this. So that's a rant I won't repeat here. So what's wrong with this? When we have, you know, when we have primitives and we have these unconstrained types, then what often happens is this is how classes get large. This is how I see lots of different responsibilities, logic dispersed, not just sort of throughout one class, but often throughout multiple classes. And this is where we see other code smells crop up. So one is where, you know, you have to go and change it in multiple places. The code smell, shotgun surgery, those kinds of things, because one of the really fascinating things is that until you have a name and a place for something, you don't often see that there's a missing name and place for something. It's not until something comes into being that you start to see, oh my gosh, all this stuff that was spread throughout the code, now there's a place for it. And so when I solve primitive obsession, this is something that that I was finding over and over again, that by sort of pulling on this thread a little bit, or planting a seed, all of a sudden you know, a well-formed thing grew out of it. And so some of the responsibilities, even if they're just implementing the constraints, that's still something that is mixed up then with behavior that this other class doesn't need to be directly concerned with. Not self-documenting. So another thing that when we use unconstrained types, one of the things that happens is we don't know anything about it. So an example of that is, let's go here, is, for example, these two things. So this is from a project that I use in my class, as well as elsewhere, to sort of demonstrate some refactorings, because it's rich in problems, rich in code smells. But if we look at these two variables, we don't know a lot, right? In fact, we know very little. And you know, put aside the fact that, oh my gosh, we shouldn't be storing any monetary amount in a double. So put that aside. That aside, what is this, right? We don't have information that we might really find useful, and it may not even be a great name. Yeah, right. What currency is it? Is it shekels, rupees, or is it dollars, euros, pounds? Who knows? And this, it's an int, and it says stock, and we may know from the context, okay, maybe it's something having to do with how many of these do we have, but we don't know for sure what are these things. And so typically, yeah, so George says beef stock or vegetable stock. That's not the stock I usually think of. Usually I think of, if I'm trying to think of something, like, you know, wait, we're not talking equities here, right? We're talking something else. And so it really ends up relying a lot on having picked a good variable name, which, as we know, is not always something we want to rely on. So because this is just some int, we don't have a lot of information, and we could write some comments, but again, you know, hopefully we see that writing comments isn't always a way to sort of deodorize code smells, as Tim Ottinger mentioned once to me. And so by having these be, you know, these primitives, these unconstrained types, we really don't let the code self-document. And that's, you know, that's one of the things that I like to see in code. Right, so it lacks units and range. That's sort of the typical things that are missing. But ultimately, it's hard to test. And the reason it's hard to test is it's not by itself. I can't test all the things having to do with tracking, in this case, the inventory of items, or tracking how much things cost and are things multiplied and added and so on correctly, because they're intermixed with all sorts of unrelated behavior. And so, you know, we'll often complain about sort of classes being too large, but a lot of times, again, we don't often get good guidance on how to split it up. I personally love the single responsibility principle, but I don't find it very actionable. I don't provide it with any kind of guidance of do this, look for this, and then do this. And so when I'm teaching things, I want to provide those kinds of ways of looking at it. And absolutely, as George mentions, you can mix these things up, and we'll see that in a bit, right? I could, you know, unintentionally, you know, mix up units that have nothing to do with each other. So let's dig into a more concrete example. So on the top, we've got the number line of a standard int. In Java, that ranges, you know, from -2 billion to +2 billion. But almost everything we have in our code, unless it's doing just math and it's a calculator, in other words, doing calculations where the, you know, everything kind of is unconstrained, usually there's domain, right? There's what is the application doing? What are the things it talks about? So if I have a game where we're betting, so like my blackjack game that we'll look a little bit at, it's certainly not unconstrained. And so at some point, we've got to make sure that that wager is in some kind of valid range. Maybe we allow 0, maybe we don't. Does it have to be greater than 0, or does it have to be greater than or equal to 0? I don't know. Maybe there's some validation somewhere. Maybe there's inconsistent validation. In one place in the code, 0 or more is fine. In another place in the code, no, it's got to be 1 or more. So again, all these things about, you know, this things spread out and so on is because we're just using a lot of these unconstrained types. But the minute we create a new type and incorporate and encapsulate all those constraints, a lot of those problems go away. So sometimes it's we're implementing a range, and sometimes we're implementing sort of something that's maybe more of a set, right? Maybe a non-continuous range. So I remember when I was first doing sort of making these diagrams, and I was looking at what is the range of local date. So local date is relatively new for those of us who've been around for a while. When finally we got a fairly rational way of dealing with dates and times in Java. Turns out local date has a huge range. Basically, like almost a billion in each direction in terms of years. I don't know about you, but I don't find that terribly useful. But you know, it's got that capacity. But we never use that full range. Maybe there are places where we do, but there's almost always we're going to use some subset of that range. Sometimes it'll be some continuous range like birth date, and we have a constraint. Well, maybe we're not going to go past 150 years ago if we're talking about somebody who's living, and certainly not greater than the current date because they're not born yet, so therefore we can't talk about a birth date. So we have some of those kinds of constraints. Other times, like this one, which actually comes from a project I'm working on that deals with stock options, publicly traded stock options that have expiration dates. And so those expiration dates not only are just a set of dates, but they also sort of, you know, expire, and new ones come into being, you know, almost every week for some stocks. And so even there we have an even more constrained type. And speaking of sort of swapping dates, I don't want to accidentally pass an expiration date where I expect a purchase date, because those are two different things. When I purchased this thing, right, when I did the transaction, it's a date, and underneath is probably a local date. But it has different constraints and different valid values than expiration date, which has a very fixed set of values that would be validated from some data source from the market data. And I wouldn't want to accidentally mix those up because that would wreck things. So basically, the solution to all this, in case you haven't guessed, is to create new types. Lots of new types. We don't create enough new types. What I hope people do is basically create new types, right? You get a type, everybody gets a type. Because especially in a language like Java, where it's statically typed, the compiler can do things and tell us things at compile time that other languages like JavaScript or even TypeScript can't tell us, is we want to create more types. And why not? And it's really interesting to me, like, even I look at code that I wrote, even just a year or two ago, and I'm like, oh my gosh, I've got primitive obsession all over the place. And so, in case I didn't mention it before, I'm sorry, but not sorry that you're going to start seeing this all over the place. Or maybe not, and you're lucky, but probably most of you, if you work in code, you will see this all over the place. And you're going to start questioning every single unconstrained type primitive that you see and wondering if maybe there's a type that should be pulled out. And so for me, one of the sort of pushbacks I get against this is performance. I'm going to go out on a limb and basically say, in my experience, performance is not the problem. In my experience, the systems I work with, and I've worked on some systems that you would think performance is really important. As George says, if your eyes are open, you'll see it. But to me, readability and testability trump that, because we can always focus on the bottlenecks. We can always focus on where the performance issues are. But we can't figure that out if we can't find it and can't read it. And so I've had some interesting discussions with folks after the last time I gave this version of this talk. And we teach a lot about sort of big O notation and stuff. I mean, I remember there was, and we emphasize that in even development engineering interviews. And so sort of this overemphasis on performance. And I go into companies and we look at this, it's like, your performance problem is in this 40K of JSON that you're transporting back and forth. It's not because you had 10 more classes than you did before. And so, in fact, in Java, having additional classes and additional methods, if you're starting to see problems because of that, you got other problems. So Artie asks about how to avoid source bloat. So in terms of bloat, I think a lot of times we don't modularize things well, right? So we have, at the lowest level, we got methods, and we put code into different methods. And then those methods are in classes, which we end up having too few large ones. So I'd rather have more smaller ones than too few large ones. Because then once you break things up into smaller ones, right, like I'm suggesting that you do more of, you can then organize those in packages. And so to me, it's not about bloat, it's about disorganized, untidy code organization. So I want to be able to tidy things up. I want to be able to put things in their place. And packages have names. And so we can divide, and that's what namespaces are for. It's not for the compiler. Compiler could care less. It doesn't care if you have one package with 1,000 classes or 500 packages with 2 classes each. It doesn't care. It's for us humans. We're writing code for each other. And so that's why, to me, readability is so important, because we write it for each other. And so if you have too many classes, then you've got an organization problem. And it is certainly possible that maybe you actually do have just too many classes. But in my experience, it's it's often the opposite, that we have classes that are just doing too much and aren't quite sure how to split them out. And so in terms of, like, just to give you a flavor, and then we'll look at some concrete solutions. So on the left side here, I've got some things that I might pull out in my blackjack game, or so in terms of tracking how much a player has. There's how much they have, their balance, or amount that they have, and that might be one type, and maybe it's constrained in a certain way. Maybe it also has some behavior. There's deposit amount, and that may have different. Maybe we only allow deposits up to a certain amount, and that might be a different type from withdrawal amount. Certainly, deposit and withdrawal, we probably don't want to have negative, and maybe there is some upper boundary, and maybe there's an upper boundary that's different for deposit than withdrawal. But even if it's not a range that's different, as George mentioned earlier, I don't want to mix up deposit amounts and withdrawal amounts. Bet amount and bet amount might look very similar, but it probably has a different constraint. It might even be not continuous. Maybe you're working with chips, and so it's 5s, 10s, 25s. So things are different. Then on the right side, we've got quantity, inventory level, right? So you kind of get the idea that there's these things that we can express in our types that we often just use unconstrained things. And absolutely, I haven't even touched on strings, where there's all sorts of, if I understand what Bob is saying, like there's all sorts of constraints on strings that we use, right? Email addresses. Now, I'm not going to necessarily have a type that's going to fully validate that up front. That's a fool's errand that I've learned. But we can still say, sort of, what does it look like? We may have some way of validating it. But really thinking about, is this variable carrying its weight in terms of what is it doing? Is there code that's checking range on this thing that's spread out that we can encapsulate somewhere? So one of the first ways to solve primitive obsession, so the solution is create more types, and hopefully you're not against creating more types. And so the question is, what kinds of types? So the first kind of types are basically enums, and these are great if you have limited options that at sort of code time, at compile time. So some examples of that, we'll see some examples in blackjack. So we've got a playing card, suit and rank. Those are definitely enums. They're not going to change. There are 4 suits in a standard deck. There are 13 ranks in a standard deck. And those aren't going to change unless you change the game. And so those are things that can definitely be enums. Lots of times outcomes or states, right? So what state is this thing in? The game is in progress, or the game is over. The game is over, and then there's sort of game outcomes, which is a separate sort of set of final states. And these would also be good as enums, as opposed to strings, which is what we do a lot of times. In this options trading system, puts and calls, right? That's an easy enum. And a lot of times, things that may look Boolean are better served by actually being enums. So one of the things that this allows us to do when we get rid of primitive obsession is turn what sometimes looks like logic. Actually, it's really a constant that we may not have thought about in that way before. And so here we have an implementation of card, or at least part of an implementation, where we're trying to figure out what is the point value of a card, right? What is its rank value? So in the game of blackjack, face cards, Jack, Queen, King, represented here by the JQK, those are worth 10. An ace is nominally worth 1. There's special cases about that, which I don't need to go into. Otherwise, the 2 through 9 are worth whatever they say on the card. But if we pull this out into its own class, right, into an enum, then this behavior basically just becomes constants in the new enum. And so then what's really interesting, and this is where it gets into testability, I might have had tests for this. Am I sure that it's calculating the rank value correctly? Right? Are face guards treated as 10? Is an ace treated initially as 1? And so on. But once we do this, I don't need to test value anymore. It's literally a constant. Right? If I want to know what the value of a jack is, I ask it, what is your value? And if you're if you've already started to see primitive obsession, you might wonder, is that int here for value suffering from primitive obsession? Possibly. Maybe there's a rank value primitive sort of type that's that might fit, and we'd have to think about that. But this is, as I said, this is what happens. Occupational hazard is you now start seeing it everywhere and start thinking about, should I be really revealing this as an int? Is that something that I want to do? Is somebody going to do something with that? What are they going to do with it? What are they going to use that for? What's going to happen with it? And so we'll see some of these questions in a bit, but this is sort of what happens. You start looking at code and you can't help it. The other nice thing is in recent versions of Java, if we happen to be using one of these enums with a switch statement, the compiler can tell us if we've covered all the cases, and you don't need a default and things like that. And so that can also help us write better code. And so sometimes the testability needs go away because they're literally constants, and we're not checking any behavior anymore. Sometimes we still may need to test some things, but now this is in its own class, and so it's easier to test. And we'll see some more of that. So sometimes an enum isn't good enough. Maybe there's lots of choices, and maybe they're not all known at compile time, or they change more frequently than we want to recompile and redeploy the code. So then we might think about a value object. So Bob asks about exception handling with strong types. So I'll talk about that a bit more, but what's really interesting is, and one of these days I'll figure out where I heard this. So there's this saying, parse, don't validate. And I'm sure it came from, Haskell or OCaml or somebody talking about, much more strongly typed languages than Java. But this idea of where do we get input from, right? We're, a lot of times worried about validation and things like that. But how did something come into our system in the first place? And I've been thinking about this a lot ever since I started thinking about hexagonal architecture, ports and adapters, those kinds of things, where there's a clear separation between the outside world and our core domain. Our outside world deals with strings and numbers, and our core domain deals with types. And so there's this point somewhere where we transition from strings into types. And so at some point, we're going to get some input. Maybe somebody typed in the name of a card for some reason, because that was something that we had to take in. And the question is what do we do with that? Well, if we simply validate it and we still hand it around as a string, then we're constantly worrying possibly about revalidating it. And then maybe once it gets into our core, we have to revalidate it again. But if we parse it immediately into a rank, well, now we know it's valid. We don't have to check that anymore. So there's some of that, exception handling around sort of validating goes away, or at least is pushed sort of to the edge, which is where I like it. There may be other constraints that we have to check in the core, but the idea of having more types means we don't have to constantly revalidate. There's other sort of exception handling that also have to do with sort of constraints and comparing against other things. So for example, like deposit amount, well, I can't, so probably withdrawal amount is better. I can't, at least in Java, in other languages you might be able to do this, but in Java I can't create a type that would enforce that when the withdrawal amount type instance is created, I won't get a, there's always enough balance to withdraw that amount. Can't do that with types in Java. But, I can more easily compare, and I at least am now not worried about, is this type well-formed? Is this thing valid? There may be other things I have to check, but at least I can validate that. Yeah, so this boundaries are valuable, right? That's what we like to have in our systems. And enforcing these kinds of things at the edge really help us focus based on the more important stuff. To me, like that kind of stuff, I don't like dealing with. Like, do I have to deal with again with this being greater than 0? I just want to deal with, like, I got to check to see if there's enough money here to do this operation. And so feeling like that's more at the business domain level of working rather than what feels like administrivia and sort of uninteresting work. So good question and good point. So value object. So we'll look a little bit at value objects, and then we'll look at some code. So some of these examples are ones you're probably already familiar with. So for example, in the United States, the zip code is not a number. It uses digits, but it is not a number in the way that at least I think about numbers being things that you can multiply, divide, and do math on. In fact, things like the leading 0 is important in the zip code. 02134, which is a zip code that I will never forget, because for those of you as old as I am and remember not the application called Zoom, but a show called Zoom, 02134 was the zip code, and I think it's somewhere it's in Massachusetts. I forget exactly where. But the leading 0 is important. So it's a string. It's a bunch of digits. And so it's not, it looks like a number, but it's not a number. Other countries have, much more clear in other countries with their postal codes, like the UK or Canada, where it's clear that it's not a number. But these are value objects. They are things that we need to display and work with and so on, but we're not really doing much in terms of necessarily of operations. Yeah, as Martin says, fail fast, right? I want to fail fast, and I want to fail at the edge. I want to fail as close to where that problem occurred. And yeah, Social Security, also not a number, even though it's a bunch of digits and it looks like a number. It's not a number. At least it's not a one we would use in arithmetic. And like the first 3 digits in the Social Security number have certain meaning about where you grew up in. Anyway, so certain these kinds of things. Money, this is a big one, of course, right? All sorts of constraints, all sorts of things around what currency we're working with. Even if there's an assumed currency, it's nice to know that we're working with that, and there's an amount, how decimals work, all that kind of thing. Birth date, as I mentioned, right, has constraints. It's not just a date. It's a date that if we wanted to validate it, we would validate it, and say that it can't be a future date, and it can't be a past date, maybe against some, some time ago. Color is another typical example, and identifiers. This one is really interesting. So I first came across this idea way back when, a book by Vernon Vaughn called Implementing Domain-Driven Design. And in his code examples, he used basically types for identifiers. So identifiers, they may also be numbers, but again, they're not really numbers, or at least they're not numbers that we do math on, or maybe even compare in any way. And so the fact that they happen to be digits, Sometimes they're not. If they're UUIDs, they're hexadecimal digits. But they're identifiers, and what we sometimes call opaque identifiers. They don't really have, you don't do anything with them other than say, find me the one associated with this. But when you have different kinds of objects, users versus customers versus orders versus other things, you can't mix up those IDs. You can't look for a customer ID when you have an order ID. At least not in the systems I work on. But if they were just longs, you could totally mix those up. I've seen methods that accept 5 different variables, 3 ints, a string, and a long. And I'm like, if you swap any of those ints, and I don't care, how much help the IDE gives you, the compiler doesn't care, you've got a problem, and you may not notice it. So we want to think about constraining our primitives and then wrapping that and putting that inside of a new class, whether it's a wager that can only be between 1 and 100, or an expiration date that can only be a set number of dates, and what a valid expiration date is, may depend on other things. So there's possibly some logic there. That putting them into their own types not only helps us with some of these constraints and validation and not mixing things up, but also makes testing much easier. So sometimes, though, we need to hold state, right? We need to count things. We need to hold on to things. The things we've looked at so far, you can sort of look at as immutable. They don't change very often, or you swap out, one object for another. And so some stateful types might be an inventory level that gets increased and decreased based on certain things. A blackjack hand that we'll look at, or an order quantity that, once you're looking at the shopping cart, I may want to increment or decrement to increase or decrease the amount of those candy bars I want to order. So one of the things that I mentioned as being a potential candidate for primitive obsession is a list of card. Sorry, basically a list. In this case, a list of card. Now there are 2 places in this game that happen to store basically a list of card. One of them is the deck, and so we can see that it has a list of card. And this is a case where this isn't suffering from primitive obsession. This was the solution to primitive obsession. And here, what we see is there's basically constraints being applied to this list. One of those constraints is you can't actually get to that underlying list. In fact, from the outside, you don't even necessarily know that there's a list, because they're basically 2 public query methods, right? 2 methods that you can make requests. One that's sort of a command, one of those special command methods. But basically, there are 2 public methods. One is how much is left, what's the size of the cards remaining in the deck, and the other one is give me a card. And nowhere are we exposing anything about what the underlying type is. And this is, for me, one of the fundamentals of OO. But applying, sort of solving primitive obsession gets us there. And so this doesn't have primitive obsession. This is a solution for primitive obsession, because we might have had a list of cards as a deck and have this code in another class when it really should be by itself. And so because it's by itself, it means it's very easily testable. Whereas here in game, we've got these things that are lists of cards, One is holding the dealer's hand and the other one is holding the player's hand. And so in the game Blackjack, there's a bunch of rules that we have to apply. You get dealt cards, your cards, the cards have values as we saw with rank value. And there are things, information that we want to know about those sets of cards, those list of cards that we have. There's a total value of the hand. And for that, there's things that we do with those hand values. For example, to figure out who won, we compare the values of both those hands. But if we look at the code, if we look at sort of the usages of this, we see code like this, where we're calling a method, handing in this list, and then calling a similar method and handing in this other list, and then taking the values of that and comparing it. And this is a case where it certainly seems like these suffer from primitive obsession, right? We see references to comparisons. So one of the things I look for when I'm looking to see, is this actually suffering from primitive obsession? Okay, it's an unconstrained type. Is there logic? Is there validation? Are there constraints being applied that are spread throughout this code? Here, there's actually no sort of constraints per se. There's no validation, but there certainly is logic, comparisons, which we sometimes call behavior. And so we're checking to see, are the hands equal? Is one less than the other? Comparing against some literal 21. Is there something magical about 21? And it's hard to say looking at if you didn't know that this was busted and there was this method here, just looking at this by itself wouldn't tell you anything. Unless you knew the rules offhand of Blackjack and that 21, oh, I know that's a special number. And so this idea of looking at usages, this is what I'm doing all the time when I'm okay, is it suffering from primitive obsession? Yes, it's involved in all sorts of logic. The dealer has other logic it's associated with. And so, okay, this is definitely suffering from primitive obsession. And so the way we solve this, there's a specific way, there's actually a specific sequence of things that I do, and I'll talk about that in a minute. But often what happens is once we refactor, I'll pull the old baking show and say, now I've refactored this into its own class. So voila, we now have hand. But this is not helpful, right? All we've done is sort of move this over to another class. What we really want to do is pull over sort of some of the manipulation. So now we actually have pulled hand out into its own class. And so that means things that sort of code that references this list is now somewhat in here. So this is sort of the first step that I often do is basically pull over, create the new class, and then pull over all the code so that no longer do I reference the list directly. Right, so where this is used in game, instead of a list of cards, now it's just a hand. And so now, instead of calling some method and handing that list and having it calculate things, now we call methods on that object. So much better. Except we have a different problem. So Bob says, objects that are only data but no behavior, is that an object? That's a very philosophical question, or maybe not. But that's, we often refer to objects that have data but no behavior. Sometimes that's fine if they're just data carriers that are crossing a boundary. So for me, from the hexagonal architecture standpoint, those are data transfer objects, and that's fine. Their sole purpose is to carry data, possibly in forms that are easy for other services to consume. But there is no behavior associated with that data. The bad type is an anemic data model. We've got data in objects, and then behavior is elsewhere. And that's exactly the next thing we're going to look at, which is once you do sort of an initial extraction to, in this case, hand, we find that great. First of all, one of the things I always forget to mention is like, oh my God, this is much more testable. I can test value more directly, right? I can test draw card from, I can test, some other methods, but there's other behavior that's still left over here. So this behavior right here, right, is the dealer hand value greater than 21. Turns out that means something from a domain standpoint, right, from our game logic standpoint. Here, this is other logic that is in game. It's in this other class, and it should be somewhere else. And before we created hand, there was no other place to put it. So it may have felt, to those of us who were experienced, like this doesn't feel quite right. And maybe we refactor it out into an is player busted method, so we feel a little bit better about this, but still, like, maybe there's a better place for this. But once we created this new class, hand, all of a sudden there's a place for it. And we discover that there's basically the flip side of primitive obsession often reveals feature envy. So feature envy is basically behavior logic comparisons done against data in another object. Basically, we're doing behavior with data we don't own. And so I might have some code in a drink machine class that says reduce stock. And what it does is basically directly ask this thing, give me your current value. I'm going to do some subtraction on it and then set the value back. Or I'm going to do a comparison to see if you have sufficient amount. I'm going to do a comparison and then figure out if that's true or not. So this is feature envy. And invariably, when I pull out something to solve primitive obsession, create a new type, and then pull some behavior in, now it's a little bit more testable, it becomes obvious because of the other attribute of primitive obsession. So remember I talked about, it's not just, is this instance variable an unconstrained type? But do I have methods like this, right, int value, that return an unconstrained variable, an unconstrained type? And who's calling this? And why are they calling it? What are they doing with it? And so here are the handy find usages, tells us who's using it and what are they using it for. Now there's some places that have to do with display, and I'll talk about that in a bit, but look at all this behavior, right? Comparisons with other instances and comparisons with absolute numbers. This is now clearly feature envy. And so we can now fix this. And there's some ways to fix this, some refactorings and move instance method and some automated ways to do this. But the hard part is seeing it. And for me, until I really started seeing this everywhere and jumping at any kind of unconstrained type, and looking at how is it used? Is this feature envy? Is there logic going on here? That's something that really changed the way I look at how I think about what to refactor. And so once we refactor this and we say, okay, I'm going to eliminate all usages of value, or at least external usages of it. And so now all that behavior that was spread elsewhere is the hand busted, right? Busted is a technical, it's not a technical, it's a domain term, means you're over 21. Can I take two hands and find out which one beats the other one, or are they tied? What's called pushes, information about whether a dealer should hit. what I've done is now encapsulated all that. And now this is almost trivial to test. Because all I have to do to test this is if I want to test if this method works, I create a hand, stuff in some cards, and then test it. I'm no longer sort of having to create more objects or more complex objects than I need to, right? And this is what we want from our refactorings, is to create these things that are easier to test. And now these become really much easier to test. Then the other question that comes up is, do I want to reveal this value as an int? Because one of the things that happens is if you reveal unconstrained types, people who are looking at the method may not know that they shouldn't use it for calculations or comparisons. And so the question is, well, I don't want to return an int. Maybe I can return something else, right? Maybe I can return a hand value. Or maybe I can just return a string, because that's all that's needed is used for display. Now, there's some tension there. Do I use an int or do I use a string? Do I use another type? That will depend on, am I worried about display for a specific output mechanism, like on a terminal or on a display that can only display numerics? Or is it going to be something richer that is a full desktop GUI or web-based GUI and can show fancy images and therefore needs different information? So there's sometimes tension in terms of what do we want to pick? But at least I'm thinking about it and asking that question. So there's a whole set of refactoring techniques that I'm not going to walk through those. I'm actually working on some videos that will walk through it. But at a high level, or sort of in a summary, one of the first things that I do when I want to actually fix this primitive obsession, and there are two kinds: scalar ones, right, numbers, and then collection or abstract data type ones is slightly different. It turns out that first you want to fix feature envy. Oftentimes there are getters and setters, and you want to get rid of those because you want to pull in everything that's doing direct access. And then you remove those getters and setters. And now all that code is in one class. And then you can start moving it over to another one. And so there's a few special techniques I use to really leverage the automated refactorings that we get from a tool like IntelliJ, where you move it to a new class, and then you basically do a quick search and replace. And once that happens, then you can sort of slurp over the code, and it's actually really straightforward to do. Fixing the collection primitive obsession is actually fairly similar. Go through this process of you take the collection field, move it over into a new class, and then you just find usages. And then the goal is to basically find all usages, which means you're going to get all the behavior that's spread out through the code and just pull it in one by one by one by one until you now have this new class that has all the behavior, and then you can get rid of that getter. And so once you've done that, once you now have this class that you've formed and you've pulled in at least this initial sort of set of behavior, I often liken it's like you pull on a thread and then all this stuff comes along with it. Then you look for more feature envy, places where you're doing, like with the hand class is busted, things like that. You're basically looking for usages, and are those usages of that query, right? Are those usages harmless, or are they doing logic? The logic that they're doing, is that the right place for it, or is it really using that information in a way that it shouldn't? Right. So for me, this always goes back to the classic sort of responsibilities of classes and using CRC cards, right? So things like these, where you basically divide up a card into a class, responsibility, and collaborators. And it's these responsibilities. What is this thing responsible for? Is it responsible for this information? Is it responsible for knowing this? And sometimes it's not clear. And so I'll use these kind of cards to help me figure that out. And so that's, I'll look for feature envy, and if I do find it, I basically will pull it in. And often that will mean, oh, good, now I can more easily test this. And then I look for, okay, what, after I did that first of just, gathering everything together, then I'm looking for, are those methods no longer needing to be public? Are they returning unconstrained types? That maybe is another primitive obsession issue. And so going through this process, I really find has been kind of amazing as to how much easier it's been for me to figure out what to refactor, figure out what to sort of consolidate and make better. And so that's pretty much all I wanted to talk about today. There's a whole bunch of refactorings that if we had a lot more time, I would walk through. I walk through it in my class. But hopefully this gives you a flavor of what looking at code from a primitive obsession point of view can lead you to. And you may no longer be primitive obsessed, but maybe you're obsessed with finding primitives and replacing them with something else. So I'll take any questions at this point.
How many people just ask questions that are on mute?
I am wondering, Ted, primitives you said are okay in a local scope. Are there any other instances where you think primitives are okay to use besides the local scope?
So one is if it, or like I showed with deck, it already is in the right place and we're already at the right level of encapsulation, and therefore there's no reason to pull it further out because it's already encapsulated. So that's one thing. The other place, as I mentioned, is like these things, data transfer objects, where it's purely used for, I need to like in the Spring framework, I need to send out something in JSON. And the way I do that is I create an object that has basically usually strings and numbers, getters and setters, and that gets converted to JSON. But we're not doing any logic on it. The only work that we might be doing is creating the object, but other than that, there's no operations being done on it, and so therefore, it is what it is. And so that's pretty much what I look for is like, are there operations, behavior, logic, looping, anything like that on this thing that's unconstrained? Or certainly if there are constraints, that's the most obvious, like making sure it's greater than 0, making sure it's less than 15. That's an obvious one that's like, okay, this needs to be pulled out. But if there's none of that, then I have to look for, is it involved in a loop? Maybe that's something I need to look at. But if it's not involved in anything, it just happens to be a number. Oftentimes, though, those are IDs, in which case the other reason, even if they're not involved in any kind of logic or looping or calculations, is, do I need to tell the difference between these two different things? These are both longs fundamentally, or they're both UUIDs fundamentally, but I need to tell the difference between a customer ID and an order ID and a user ID.
So in those cases, would it be okay to inherit like the data types from, like if you had a user ID and a customer ID, they were both like GUIDs or something like that, would it be okay to, would you inherit them, or how would you handle that?
It generally looks like, let's see. So basically, once records become sort of non-preview, it would be pretty much a record that has a long. But
Okay.
you can imagine that this is basically just literally encapsulating it for no other reason than to provide it something that is compilable, a compilable type. So I can tell the difference between a portfolio ID and a position ID, or some other ID, or some other long that happened to be passed around somewhere.
Okay. Yeah, I like that because, like you said, I mean, I'm definitely guilty of mixing up. If I have two ints and a method, I'm sure I've mixed those up at some point.
And hopefully you found it out early with because you're doing TDD, but that happens.
Hey Ted, how do we follow you on social media or get a hold of you?
So JitterTed is the way to get a hold of me almost everywhere except for LinkedIn, where I'm just Ted M. Young. Middle initial M is important because there are multiple. There is another Ted Young that I often get confused with, although I guess not as much anymore.
And you're a Twitch affiliate, so if we follow you on Twitch, that's good for you, right?
If you follow me on Twitch, that is awesome. Yes, that would be much appreciated. I do have a Discord where we talk about this. So the Discord is my community, and so if you're interested in hearing about that stuff or chatting about some of this stuff, Canton Coders, I hang out in the Slack there, or you can join my Discord. These are the ways to get in contact with me. I'm fairly active on Twitter, so you can follow me there as well. YouTube, I would certainly appreciate a subscribe there, but and I hope to ramp up some of the stuff like the refactorings that I would want to walk through. I'll put up some videos on YouTube over the next few weeks.
Great. All right. Well, thanks a lot, Ted. Appreciate this awesome presentation. I look forward to watching some more videos of you on Twitch and learning more.
All right. Thanks a lot.
All right. Thanks, everyone.